All right, dude, we are live. What's up, guys? This is Dan Keys, and today we're going to be exploring the Hugging Face Transformers library some more. And oh, you know what? Since I am doing Python stuff today, I can probably change this image back to Python. And additionally, I can also put the Hugging Face. Oh, wait, I do have a Python image here. Never mind. We can use the Python. Just a second. Just a second. Oh, I think that's locked. Maybe that's why it's not working. Yeah, okay. That's fine. I did not mean to do that. Let's undo that. Okay. All right. Okay. And now I can probably wait. Do I have a? No, that's a Kaggle one. Though I do need this image. I think instead I'll change this image to Hugging Face. So just give me a second while I select that. You guys can't see any of what's going on right now because it's in the it's in the like preview window, like what do you call it? OBS. OBS has this I think it's called studio mode. Yeah. It has a studio mode where you are able to see um two different screens. One of them is the one in which you can do changes, and the other one is the one that is actually going to be showing the output. So once you have made your changes in the what you can call the preview thing, you can then wait just a second. Yeah, you can then um, you can then transition. You can hit the transition button, and it does this basically. So yeah, that's what I was doing. I kind of want to fix the positioning a little bit, but yeah, I think other than that, I think we're good. I think we're good. Give me a second here. Okay, all right. Um, Give me a second. Let me just get my I think I need to reopen the application, and now I should have my stream manager option, and we are good to go. So today what we are going to be doing is I'm going to be mainly accidentally hit something. Yeah, I'm going to be mainly focusing on trying to use Hugging Face models offline. So there's a couple of ways to do this. The first way is actually not just offline. I'm going to be looking into the different ways that you can use Hugging Face models. One of the ways is definitely online. So when you specify the name of a model, if you don't already have the model downloaded and cached, then Hugging Face is gonna download the model for you, and it's gonna cache it so that the next time you make such a request for this very same model, it's gonna then try and use that model if it is still the most up to date version. But if there are updates to that model, then it's probably going to re-download the thing again. In addition to this functionality, apparently use you can also use the models locally. So you can set a flag called local files only or something like that to true, and you can give it a path. So it's then gonna look for the model at that specific path, and that's kind of what I'm aiming to do because I don't want to be downloading, new versions of models each time because that's going to become a little too heavy for my internet connection. And it's also unnecessary, especially considering the stuff that I'm doing. I don't always need the most up-to-date version of a model. So I should be good with, even older versions. Okay, so that being said, we're going to create our environment. So UV um, 3.13, let's say, and I think the name should come here. I don't remember. Hold on, let's see if there's a help option. Okay, UV help VN for details. Okay, all right. Okay, so it's options and then path, right? All right, great. Path to the virtual environment, default to so-and-so in the working directory. Okay, all right. Okay, cool, great. So, yeah, that's what I'm supposed to be doing. VEnv, um, Python version 3.13. I actually don't remember. Hold on. Let's manage Python installations. I don't remember how I had installed Python 3.14. Yeah, I don't remember how I installed Python 3.14, and I also don't remember which version is currently considered the latest. Well, latest I believe is actually 3.15, but I don't know if they've like between 3.13 and 3.14, which one is being used more now. 3.15, they're probably going to take a little bit to get to it because it's still kind of fresh. At least it was the last time that I checked it. Anyways, I don't think this is going to make too much of a difference. I'm wasting time here. VNP 3.1. Actually, wait. Let's waste some more time. Python list. Okay, so I do. Okay, it's listing a bunch of different versions here. 3.138. Oh, do I not have 3.14? I think maybe I don't have 3.14. I'm not sure. Let's try installing it. Is this how you do it? Okay, it's already all right. It's already installed. VNP 3.14, and the name I want is env. That's created. Let's do this and bin activate. We need to do the same thing. Yeah, we might as well do the same thing here as well. So source env bin activate. Now here I want to install. So pip install. Actually, do I need to do uv pip 3? Okay, no, it's just pip. Pip install. I think it's just pip install transformers. Hold on. In the documentation, actually, this is a great thing. Something that I really liked is that even in the transformers documentation, they're suggesting using UV pip and UV in general, and that's great because for those of you who don't know, UV is it's a multi-purpose tool. It's great for package dependency management or project dependency management and also project management in general. It's incredibly powerful uh, creating um, creating deterministic projects or projects that can give you fixed like deterministic results. And in order to do that, it has like a very strict it has very strict rules for dependency management. That is if you want to use that. That's for like much more serious projects where you absolutely need to have the exact versions of dependencies, and changing a certain version from, this point this to point that, it could change the behavior or give you a slightly different result or stuff like that. So for that, you need like strict dependency management. That's that's great. That's the project management side of UV, but it also has simpler stuff. Like if you just want to use UV pip to install your packages in a similar way that you would using pip 3 or something like that, you can do that. And it is fast. It is fast. Okay, let's look at the installation. Yeah, see here, it mentions UV is an extremely fast Rust-based Python package and project manager and requires a virtual environment by default to manage different projects and avoids compatibility issues between dependencies. So we create the environment like this. Great, awesome. Transformers. Okay. So I don't need GPU support here. So for now, I'm just going to do, oh, wrong one. It's transformers. Yeah. At some point, I might need, look at how fast that is, dude. And just like that, it's done. Okay, so we're going to open up this project. And in here, yeah, py01.py. Great, awesome. Where was I? Yeah, so this is the installation after you're done installing. Okay. Cache directory. When you load a pre-trained model from pre-trained, the model is downloaded from the hub and locally cached. Every time you load a model, it checks whether the cached model is up to date. Just a second. Okay, it checks whether the cached model is up to date. If it's the same, then the local model is loaded. If it's not the same, the newer model is downloaded and cached. The default cache directory given by the shell environment, variable so and so. Wait, do we have that kind of an environment here? Let me see. Echo HF. It's not auto. Oh wait, we don't have the environment here. Okay, echo HF. We still don't have it here. Still nothing. Well, okay, let's try typing it in. Yeah, there's nothing here. On Windows, the default directory is so and so. Yeah, that's confusing. HF underscore hub underscore cache. Okay, cache a model in a different directory by changing the path in the following shell environment variables listed by priority. Okay, let's see if the other variables exist. There's nothing HF related. Okay, there is something XDG related, but there's no XDG cache. Yeah, there's nothing, and that is only if home HF home is not set. So I'm confused here. Okay, let's try HF. Yep, still nothing. No, don't do that. Don't do that. Okay, I did not mean to do what I just did. Now, which one was I in? Other laptop. All right. I was trying to exit this. Okay. All right. So, we can take a look at the cached thing later on. Actually, for now, I don't really need to worry about caching, and whether, the thing is cached or not. There might be, okay, let's try something here. Okay. So there is a cache, and then there's a bunch of stuff here. Is there EFGHI? Yeah, there's nothing here. I think maybe there needs to be a first run kind of thing, and maybe then it's going to get created. I don't see how the environment variable would get created. I don't see how the environment variable would get created there, but yeah. Okay. So, what was I gonna do? Oh, yeah. You know what? Yeah, wait. So I need let's go into quick start. And oh, there was another thing here. Yeah, I forgot about this. This is something else I need to look into, something called snapshot download. So it says here, to use transformers in an offline firewall, in an offline or firewalled, and oh god, do not do that. just just a second. This stupid update window popped up. I went to right click on something, it right clicked on this, and then, yeah, anyways. Okay, wait, I'm curious, what was this about to do just now? Give me a second here. Okay, so there was an inspect thing, no items found, and then there's a paste thing, which is gonna paste this definitely. Okay, all right, I guess I panicked for nothing. Okay, great. So offline mode. So to use transformers in an offline or firewalled environment requires the downloaded and cached files ahead of time. Download a model repository from the hub with the snapshot download method. Then it said refer to download files from the hub. So we're words. We are going to take a look at that. Why was that so hard to say? Yeah, we're going to take a look at that later on. In the meantime, let me just, make sure to load the thing. Download and cache a single file, download and cache an entire repo, download files to a local folder. Yep, and the idea in my case is to download the files to a local folder, and then they're saying that, okay, we have to set the environment variable HF hub offline to 1 to prevent HTTP calls to the hub when loading them. Okay, that's one method. The other method is this: if you are calling from within the code, then you can specify the flag local files only equals true, and then this is the path to your directory. So this is one of the things that, oh god, what did I just click? What did I just click that caused that? Oh, update on GitHub. I didn't mean to do that. Let's not do that. Let's go back. That's crazy, dude. Give me a second. Clicking anywhere on this line, clicking, clicking anywhere on this line clicks on this link. That's crazy. All right, anyways. So this is the installation. Let's open up Quick Start. This should kind of, yeah, there we go. So, wait, in this one small tutorial, they go over everything? That's crazy. Okay, we're not going to be looking at the trainer thing because we're not trying to fine tune right now. Um, What we are going to be looking into is loading a pre-trained model and running inference with pipeline. Okay, Transformers is designed to be fast and easy to use so that everyone can start learning or building with transformer models. The number of user-facing abstractions is limited to only 3 classes for instantiating a model and 2 APIs for inference or training. This quick start introduces you to Transformers key features and shows you how to load a pre-trained model, run inference with pipeline, and fine-tune a model with trainer. Okay, to start, we recommend creating. Okay, yeah, we can look into that later on. Where does the notebook thing come in? So this is notebook. This is CLI HF auth login. An account lets you host and access controlled models, datasets, and spaces on the Hugging Face Hub, a collaborative platform. You know what? I could try using Hugging Face's tools for some of the stuff that I'm trying to do. Hugging Face's resources. That's the word I was looking for. I could try using some of Hugging Face's resources for some of the stuff that I'm trying to do. At least to get like because I'm going to be dividing it up into multiple stages. At least to wait. Actually, no, I don't think I can do that. Yeah, no, I can't. I can't. Well, okay, to a certain extent, I could do that. To a certain extent, I could do that. Like if there's a model in which I'm going to give the input as JSON and then receive the output as JSON, I could technically use Hugging Face's resources for that. The thing is, I need to see if it's going to be worth the effort at all, because at that point, I could also just use Kaggle resources, right? Let me just open up Hugging Face. Actually, wait. They probably have the thing here. Let's open up pricing. Under pricing, they probably mention it. Spaces. So this comes under Spaces. Spaces hardware. There you go. Spaces are one of the most popular ways to share ML applications and demos with the world. Upgrade your spaces with our selection of custom on-demand hardware. So in the free tier, we get 16 GB of memory and 2 vCPUs. That is actually great. Dude, that's actually great. And then if we are paying, which at some point, like if I'm able to set up this entire architecture, and then I only have to pay, for example, I don't know, 40 cents or 60 cents or 80 cents per hour for using those resources, I don't mind doing that. I honestly don't mind doing that. At some point in the future, if I start to see that the auto clipper, I'm not even sure what to call it. It's not one application. The auto clipper system, let's call it a system, because I'm not sure what to call it, because it's one script, but within this script, we are launching multiple processes. In each process, we are loading a model and loading input into it, getting output from it, and then unloading the process and going to a next process and stuff like that. Oh, actually, I should also see how it's gonna work. The whole process thing. I have to see how it's gonna work if I'm running this code on on the cloud. Because I want to write this code so it can be ran both locally and on the cloud if you do choose to do so. I don't think, like, usually you don't need to worry about this kind of stuff, but like I need to see. I think it should be handled, because that's the job of the Python interpreter to handle all of this stuff, or whatever system is. whatever system the interpreter is interacting with. It's my point is that's the job of the Python system to handle it. And any system that claims to be able to run Python, such as this cloud environment, is most probably going to be able to run this. Like it's going to be able to do this. This being, launching sub processes and stuff like that. Okay. NVIDIA L4. Okay, this is great because with higher prices, you also get more VRAM, and that can be useful, especially if I'm doing, especially if I wanna do like VLM stuff. If I wanna do any. Okay, so it's saying that we are back live again. I think this is a new stream though because the disconnect protection ran out. That's unfortunate. I don't know how long we had been streaming for. I think 45 minutes maybe. That sucks, but it is what it is. Anyways, oh wait, yeah. Something else also just happened which I need to take care of. So give me a second while I set that up. Is it temp rust? I think, yeah, I think it is. Okay. Uh, yeah. Oh, wait. There is another thing. So I had to launch this, but I also needed to open this up. Hopefully that server is still running. Yeah, the server is still running. Okay, we are good. Yeah, yeah, great, awesome. So back to this. So I did look into Hugging Face spaces a while back. One of the reasons, just fully being honest here, one of the reasons I didn't move forward with it was mainly because of the lack of IntelliSense support. Might seem silly, right? Because that's not the focus of this. The focus is not to provide you, the developer, a nice development environment. The focus of Spaces is to provide you with, okay, I'm not going to pretend to know what they were trying to focus on, but I'm pretty sure their focus was not giving a shit about the development environment. It was more about giving the user resources to be able to run their development environment, and not even run their development environment, run the product of their development environment, whatever program they make in their development environment. The aim was to be able to run this in Spaces. This also just yeah, okay, hold on just a second. We're going to have a conversation with Gemini about something else. So we're going to leave this thing open. I can open this up again. That's fine. Let's do it here. Yeah. Okay. Hey, so I'm looking to use HF Spaces for cloud computing. Um, yeah, okay. Oh, specifically for running AI models. Models, there. I'm aware that there's a web UI for Spaces. What I'm wondering is since I have a primarily terminal based, it really sounds, each time I say this, it really sounds like I'm trying to boast about about having a terminal based workflow, but I kind of have to be specific here that it is a terminal based workflow. So in order to remain within that terminal based workflow, what tools can I use that are gonna keep me there and not make me go back to the browser or make me go towards some UI, some GUI application. Okay, since I have a primarily terminal-based workflow, um, even coding is done using NVim, DaisyVim. Are there any CLI tools slash libraries that I could use that would help me use HF spaces without having to use the web UI? Stop, stop. I don't know which model it's gonna be. Well, I don't think that's gonna make too much of a. Yeah, that's fine. I'm also curious if they changed the limit, the the usage rate limit thing. Gemini API rate limit. Okay. I'm checking on a different system. This says in the past 7 days, there's nothing. Let's do in the past 28 days. It's still showing up as full. That is insane. Well, okay, to be fair, it's showing peak usage per model compared to its limit. Oh, peak usage. Okay. But no, you know what's crazy? Based on this peak usage, it's stopping me from using the model, which is crazy. It's like, okay, in the past 28 days, you've had a request per day of, wait, hold on, let me go back here and see if Gemini is asking me to, like, whether it can write to a file or something. No. So it's doing a Google search. There's a thing for getting started with spaces, isn't there? Oh, that's interesting. You can, oh wait, I was about to say, this is interesting because you can create it with your Kaggle account, but no, it's Hugging Face account. Build, host, and share your ML apps using spaces in just a few minutes. Oh yeah, I forgot. There's usually like some form of UI that gets used for this. Um, and that usually uses either something like Gradio or Streamlit. And I haven't touched either of those in ages. Though getting back into them, it doesn't really take all that long. I am used to Streamlit. Um, at this point, I don't know if I can say I'm used to Streamlit, but like yeah, I'm kind of I'm kind of used to Streamlit. I should also check the static thing. I don't know. Okay, connect to your space with SSH or using VS Code in your browser with Git support and automatic process refresh. Great. All right. Okay, our information is ready, kind of. Gonna be honest, this is not as much as I thought it would be, but okay. It appears that Hugging Face provides tools for interacting with spaces directly from your terminal, um, which aligns with your workflow. The Hugging Face Hub, actually, okay, I take that back. This is giving the information that I wanted. I guess I'll have to be more specific with it about what exactly I'm looking for more information on, and then it's going to give me that information. Okay, there's the Hugging Face Hub library offers two main ways to achieve this. Hugging Face Hub CLI, which is a command line tool designed for direct interaction with the Hugging Face Hub, including spaces from your terminal. You can use it for tasks like authentication, managing repositories, including spaces, uploading/downloading files, and syncing space content. Okay, okay, that's interesting. This would be your primary tool for a terminal-based workflow. Okay, so at the moment I'm trying to imagine this because I do remember that storage is also kind of limited to a certain extent, as in you can store things for the model to run, but then the model the model's output, you can't really store that onto some kind of storage unless you use their dedicated like storage service, or well, use their dedicated storage service through the relevant API and stuff like that. But I don't want to use that. I could avoid using that because um, the output of like all of these stages eventually is supposed to be a bunch of timestamps, and names, and basically it can all be like one long JSON file, one long JSON block of code, which I could then copy and paste locally, and then I can have a small, little function that parses that entire block of JSON to determine what clips to create, like what the timestamps are for each clip. It'll then slice those clips out of the VOD, and also name the resulting files accordingly. So this way I can use the cloud computing resources instead of having to use my local resources. Initially, I'm going to have to use my local resources. I don't think I can get away with that for too long, though, because I'm going to have to see, because it depends on the models that I'm going to be using. And yeah, yeah, I haven't seen all of the models. To be honest, I haven't looked into like, what all I'm going to need, what all types of models I'm going to need. Fortunately, I still have that, uh, that nice bit of information that Gemini had given me for the auto clipper. So the various stages that we can uh, divide the workflow into, and the various models that can be used to accomplish different tasks and stuff. I still have that, so I know what exactly I'm looking for, and I can search based on that. Okay, anyways, uploading/downloading files and syncing space content. This would be your primary tool for a terminal-based workflow. Hugging Face Hub API, which is a Python library. This is a Python client that allows programmatic interaction with the hub, while it's more geared towards integrating hub operations into larger Python applications or for complex automation. Example, creating spaces, configuring hardware, managing secrets from a script. You could use it within Python scripts executed from your terminal. Actually, creating spaces, that's something that I would like to do. So I don't want to go into the web UI in order to create a space. I want to be able to create it from here. Though, okay, didn't they say, okay, wait. So for your primary terminal-based workflow, I recommend exploring Hugging Face Hub CLI. You can usually install the Hugging Face Hub library, which includes the CLI via pip. After installation, you can run Hugging Face CLI help or HF help to see the available commands. Wait, so I can also create, manage, and run HF spaces directly from the terminal, or even from my Python code. Wait, shit, dude, we are supposed to be doing, I just remembered we're supposed to be doing that offline, the downloading the model and using the model offline thing. So the first time that I run it, there's definitely going to be a download kind of thing. Okay, yes, that's correct. You can create, manage, and interact with Hugging Face spaces directly from your terminal using the Hugging Face CLI tool, and programmatically from your Python code using the Hugging Face Hub Python library. Okay, all right. Where do we look at the docs? There's the docs. Okay, spaces overview. Um, okay, we have built-in support for an awesome SDK that lets you build cool apps. I have a question here. Now, usually I have seen HF spaces having some form of UI. Considering that I'm gonna be running, how do I say this? Be creating, launching, and running, which would be the same thing, right? Anyways, um, the space through my terminal, I don't really need UI. How would I be giving input and getting output? Yeah, because usually that's how you would be giving the output, and actually that's how you would also be getting the input. Usually if you open up one of the Hugging Face spaces that are meant for a certain thing, like let's say it's a segment anything model, for example, it's a segmentation model that you feed an image into, and then it produces segments for you. Usually what's going to happen is there's going to be one side that takes your input. You'll have like a file select utility that lets you select an image, or additionally they might also give you like a list of images that you can select if you don't have something to upload, so you can just click one of those images and then that's going to be fed into the model. And then on the other side of the page they have the output, which is where, obviously the output is going to be produced and displayed in various ways depending on what the model is. But in this case I'm not doing UI, so um, okay, hold on. Okay, that's an excellent question. When you don't have UI, you interact with the application running in your space as an API. Instead of a web interface, um, your space exposes an HTTP endpoint that you can send data to and receive responses from. Here are the two most common ways to set this up. use Gradio or Streamlit with their API features, or build a pure API with Fast API or Flask. Okay. Even though libraries like Gradio are known for creating UIs, they can also expose an API endpoint for your application's functions. For example, with Gradio, you can often make a post request to an API endpoint that it automatically creates. This allows you to bypass the UI and get the raw output, and then you have build a pure API with Fast API or Flask. For a truly UI-less experience, you can build your space using a web framework. Like, nah, dude, I don't want to do any of this. No, this is gonna become a little bit. No, no, no. That there has to be a better way to do this. Definitely, there has to be a better way to do this. Let's take a look at this. Let's see the documentation. Spaces overview, handling spaces dependencies, spaces settings, using OpenCV in spaces, using spaces for organization cards. Okay, okay, okay. Spaces dev mode, Gradio spaces, Docker spaces, static HTML spaces, custom Python spaces. Embed your space, run your space with Docker. Okay. Um, all right. Yeah, yeah. I think yeah, I'm gonna need to do some more research on this. We can look into this later on. For now, I'm gonna stick with the thing that we were gonna do, which is this. Okay, so this is the setup Hugging Face Hub CLI package. Standalone installer. Okay, let's take a look at this. Upload files. Sharing your files and work is an important aspect of the hub. The Hugging Face Hub offers several options for uploading your files to the hub. You can use these functions independently or integrate them into your library, making it more convenient for your users to interact with the hub. Whenever you want to upload files to the hub, you need to log in to your Hugging Face account. All right, yeah, that makes sense. So I think this would be more for, I don't think this would be for spaces, would it? Okay, no, I'm wrong about that. It could, because I was about to say that it would be specifically for like models, but no, this could be for a data set, a model, or a space. Depending on your repo type, you can optionally set the repository for so and so, so and so. Okay. Hugging Face Hub, HF API, upload file. Okay, great. Awesome. What about uploading a folder? There's an upload folder thing as well. All right, cool, cool. So I think I am gonna be using. Wait, what's this? Oh, actually, I should look into all of these guides. Okay, let's look at the file system. Interact with the hub through the file system API. In addition to the href API, the Hugging Face hub library provides href file system, a Pythonic FS spec compatible file interface to the Hugging Face hub. The href file system builds on top of the href API and offers typical file system style operations like copy, move, list, disk usage, so and so, so and so, so and so. Okay. List all the files in the directory where? Here. Oh, that's interesting. All right, okay. Yeah, this can be useful for me. This can definitely be useful for me. Repository inference. Let's take a look at inference. Running inference on servers. Inference is the process of using a trained model to make predictions on new data. Because this process can be compute intensive, running on a dedicated or external service can be an interesting option. The Hugging Face Hub library provides a unified interface to run inference across multiple services for models hosted on the Hugging Face Hub. Okay. Inference providers, a streamlined, unified access to hundreds of machine learning models. Okay. Inference endpoints, a product to easily deploy models. This is for like individual models, right? Yeah, this is for individual models. This is not for, yeah, no, no, no. Is spaces mentioned anywhere here? I don't see it. Space runtime. Give me a second. All right, duplicate a space, fetch current runtime, manage secrets, manage hardware, manage state, pause state, restart, set space sleep time. All right, okay, cool. Give me a second here. Just a second. I'm looking into how to install this. I think here I'm going to use this method instead of the pip method that was mentioned. And this is getting it like directly from HF. So that should be the most latest one as well. Once we get it, oh, we can do it using UV as well. Using UVX, just like there's pipx. The easiest way to use HF CLI is with UVX. I didn't know this was a thing. I knew pipx is a thing. Pipx is used to install specific Python like binaries globally. So if you have binaries like Frogmouth, for example, which is a TUI based markdown viewer built using textual and Python, you can install that using pipx, and then it'll be globally available on your system. One of the reasons you need to do this is because Python doesn't, or now I think Linux. I don't think it's Python specifically. I think it's Linux that doesn't allow you to install packages globally unless you do like specific things to make it allow you. By default, out of the box, it's not going to let you do that. And in general, you probably don't want to be doing that anyways. Pipx is great because even though it's a global thing, it's not necessarily installing it globally. It still maintains a separate, isolated environment, so you don't have like dependency issues. So pipx is still a better option than using pip install global. And now let's take a look at UVX. Tools are Python packages that, wait, why did we come to UV tools? What happened to UVX? Weren't we looking at UVX? Back up. Oh, this is bringing us to tools. Okay. Tool versions, UVX. What is UVX? Unless a specific tool is requested, UVX install will install the latest so and so so and so. After that, no, this says UV tool. UV tool install when UV tool install will install the latest available of the requested tool. UVX will use the latest available version of the requested tool on the first invocation. After that, UVX will use the cached version of a tool unless a different version is requested. The cache is hold on, dude. Unless after that UV will use so and so is requested, the cache is pruned, or the cache is refreshed. So okay, if I'm getting the difference here, UV tool install always installs the latest version, but UVX will install the latest version the first time that you try to install that, and then it's going to cache it, and the next time you try to install it, it's going to install the cached version unless a different version is requested. So at that point, you have to request a different version. So I mean, okay, I could just use UV tool. It's good to know the difference, though. Definitely, it's an important thing to know. But yeah, see the tools guide for an introduction to working with the tools interface. Okay, let's take a look at that. Many Python packages provide applications that can be used as tools. Use UV. UV has specialized support for easily invoking and installing tools. The UVX command invokes a tool without installing it. Oh, that's interesting. I didn't realize it does that. This is exactly equivalent to UV tool run rough. Okay. UVX is provided as an alias for convenience. Hold on. UVX is not installing. It's okay. Is that why it doesn't install again and again? It only installs it the first time and then caches it so that it can then just keep running that. That's its version of installation. Like, is that what's going? I need to look into this. I can like uninstall Frogmouth and reinstall it. I need to first see how something becomes installable using UV something something, using UV tool install or even UVX for that matter. But yeah, okay, we can go back to this thing. This is the easiest way to use the HFCLI. No, the easiest way to use the HFCLI is with UVX. It always runs the latest version in an isolated environment, no installation needed. Make sure UV is installed first. See the UV installation guide. Okay. Installation with pip. Okay, great. HF auth login. What does it say? Hugging face. That's interesting. Who am I? Okay. All right, so this is all after you've logged in, right? You can download an entire repo, download multiple files, download a dataset or a space, download a specific revision, download to a local folder, dry run mode, okay. All right. Download timeout. On machines with slow connections, you might encounter timeout issues like this one. To mitigate this issue, you can set the timeout. Okay, all right. Upload. Use the HF upload command to upload files to the hub directly. Internally, it uses the same upload file and upload folder helpers described in the upload guide. In the examples below, we will walk through the most common use cases for a full list of available options, so on so. Okay. All right. Okay, okay, okay. Create a repo. All right. Okay, something about the cache. All right. Okay. HF jobs. Run compute jobs on HF infrastructure with a familiar in Docker-like interface. Directly run Python code. Wait, this is an option. Hold on. Hold on. That's crazy. Wait. HF Jobs is a command line tool that lets you run anything on Hugging Face's infrastructure, including GPUs and TPUs, with simple commands. Think Docker run, but for running code on A100s. Hold on, dude. I need to read up on this. Jobs is available. Oh, Hugging Face jobs are only available to pro users and um, team or enterprise organizations. Okay, that's fair. This is definitely a much more this is an interesting thing. This is much more high level and for the ease of use and of course for the resources, like you have to be willing to pay for this. And this is interesting. It's not even hourly. It's only pay for the seconds you use. Actually, I think even that hourly price, I think it's billed in a different way. I forgot what the thing was. I did read up on the pricing a while back. Um, but yeah, yeah. Okay, okay. This is jobs. Run UV scripts. Are we just doing the jobs thing right now? Oh yeah, this is all jobs. Jobs, jobs, jobs. Endpoints. Okay, is endpoints also? No. Okay. Use HF endpoints to list, deploy, describe, and manage interface endpoints directly from the terminal. Right. Okay. Uh, where do we go from here? Let's take a look at manage your space. We have to look at the entire like space guide, but yeah. In this guide, we will see how to manage your space runtime, which is secrets, hardware, and storage using so and so. Oh, this is, yeah, okay, great. This is teaching us how to, wait, I accidentally opened this up. Hold on. Where am I right now? I'm here. Spaces launch. What is Spaces launch? Oh, I should probably close a couple of these before everything crashes. So I can close the UV thing. I can close this. Download files from the hub. Let's keep that. Give me a second. Let me hydrate, and then we can continue reading. Okay. Honestly, I also wouldn't mind setting up a very simple kind of UI in which I can like give input and get output. But I was hoping to just use the cloud resources and get the output that I need without having to set up UI. I was hoping to just get the output that I need. And it kind of seems like I would need HF jobs for that. Otherwise, I would have to use whatever, system they have here and somehow make that work. What is dev mode? This feature is still in beta stage. This feature is okay. This feature is still in beta stage. The Spaces dev mode is part of Pro or Team and Enterprise plans. What does it do though? Dev mode is a feature that eases the debugging of your application and makes iterating on Spaces faster. I feel like okay. You know what? I feel like setting up Spaces directly with um, the web UI. For now, I think that's the best option because I'm still relatively new to learning about Spaces. Um, I do have some knowledge with Streamlit, but like from what I remember, there is a major difference between how Streamlit works and how Gradio works. One of them is like more stateful, and the other is like more just you tell it whatever you want drawn. And obviously, each of them has like pros and cons. Um, uh, yeah, I think I'll stick with Streamlit because I have experience using Streamlit. I did touch Gradio initially, but like I very quickly switched to Streamlit. The option to use Streamlit as the default built-in SDK for Spaces is deprecated. If you wish to deploy a space with Streamlit, please pick the Docker SDK, then use the Streamlit template. Oh, they are explicitly pushing Gradio. That's interesting. Actually, that might be unfair to say. That might be unfair to say. Maybe they had their own reasons for doing that. No, I don't know how this has been implemented. They're still giving the Streamlit option, so I don't want to be unfair and say because when I see something like this, I'm reminded of like how um, in Kaggle courses they are pushing TensorFlow more than PyTorch. Um, and I'm like even as I'm going through the Kaggle learn course, when we eventually get to the deep learning part, I'm going to forcefully do my own PyTorch thing and not do the TensorFlow thing. However, in order to finish the exercises, I'm going to need to do the the PyTorch. I'm going to need to do the TensorFlow thing. So what I'm going to do is I'm going to kind of cheat but not cheat. I'm going to use Gemini CLI, and I'm going to tell Gemini CLI that, hey, this is the situation. Here's what I'm trying to do. Okay. Um, in the exercise, they want us to use TensorFlow. For my own personal knowledge, I don't want to use TensorFlow. I want to use um, PyTorch. So what I'm going to do is I'm going to describe the exercise to you and give you like the template code that they have given. I want you to then convert this to a PyTorch exercise, have me finish the exercise, and then give me the actual TensorFlow. Um, or in their case, I think they were using Keras. But yeah, give me once I finish the Python version of the exercise, then you give me the Keras answer, the Keras version of that answer, and then I'll paste that in there. So that's how I'm gonna actually complete the thing, but in my own way, not using Keras. I mean, addition. Actually, no. You know what? I don't need to do that. Um, they have a solutions. I just remembered that, dude. They have a for every single one of these exercises, they have a solutions section. Like they give you the solution. You will finish the exercise no matter what, even if you can't figure out. a single one of those cells, a single one of those, um, what do you call like sections within an exercise? Anyways, you will finish that entire exercise notebook no matter what. Okay, what comes under static HTML spaces? I'm curious about that. Um, Spaces also accommodate custom HTML for your app instead of using Streamlit or Gradio. Set SDK to so and so. Okay. A Sketchfab model in Spaces. Draw and diffuse the rest. Okay, I don't think this is for me. I think Streamlit. I think I'm sticking with Streamlit. Right. So we'll do the Streamlit thing. Great. Okay. Your first Streamlit space, hot dog classifier. Okay, transformers, torch, pipeline, image classification tool. This is the model, hot dog, not hot dog. Okay, that's the title. That's how you set the title. Then file name, for that you provide like a file picker. Great. Okay, then this is the code to do stuff with. Actually, this is not just, no, hold on. If file name is not none. Okay, so this, if a file has been uploaded, then it's going to draw two columns. And then in column one, it displays the image. In column two, it displays the probabilities. Okay, cool. I only know all of this because I've done this. I've actually made my my what was it called? Stream Deck. My Stream Deck UI that I made was made in Streamlit. It was made with Streamlit. I don't know if I ever uploaded that project. Yeah, dude. I didn't think about that. I need to go and check if I uploaded it. If I never uploaded it, then I need to upload the thing. Because I'm not going to be touching it again, as unfortunate as that is. I'm not going to be touching it again, but I have put a certain amount of effort into it. So I do want to upload it. So this is going to be one of my things like, hey, this is something that I made. If you want to use it, you can use it. Otherwise, just, this is something that I made and I would like to show it off. Uh, Hold on. Yeah, okay. This Python script uses, wait, wait, so we had the pipelines thing, right? Right, so this is the pipeline. Further from that point, we do, okay, image.openImage, so and so. This creates the data that, or this parses it into the data that's needed. And here we are displaying the image, and then predictions equals so and so. Right. So then header probabilities for P and predictions, then we display everything here. All right. What does the result look like? This is our result. So this is on the left side, we have the image. On the right side, we have the probabilities. And that's great. That's good enough. I need to see what the limit is for this kind of thing. Because I'm uploading an entire VOD, right? What is oh, the limit is 200 MB per file. 200 MB per file. That's actually not bad. You know what? That is not bad at all. That is not bad at all. Nope. Nope. We could do something here. We could do something. Is there a way for me to, no, that's going to be like way too much compression. I could slice the VOD. I could make it smaller. That's the thing. That's the thing that I could do. Additionally, hold on. Let me just there's something I have to check. Okay. Um, maybe I could just check it here. Uh, okay, let's say I decide to go with the web UI for the sake of, no, hold on. This is giving me options. So to be, wait, okay, this seems a little more effort than it's worth. I am willing to give the web UI a try. I do want to do the development in my terminal-based workflow, though. So the idea would then be to develop and test the script and the Streamlit UI locally, and then push it to a space so I can then open up the web UI and run the space. How would I go about doing this? And what's the situation with storage? Let's say my script is expecting an input that is usually around 500 MB to 1.5 GB. How am I going about things then? I was going to look something up, wasn't I? I forgot what I was going to look up. There was something else I was going to look up just now. Yeah, I forgot what I was going to look up. Anyways, we can keep reading this. I'm just going to need to like refresh my knowledge on Streamlit, and I need to remember to keep things as simple as possible. I really don't want to get too deep because I've done complex stuff with Streamlit, and it's worth the effort if you are trying to build something very complex with it. But otherwise, actually, no, what I just said didn't make sense. It's worth the effort if you are trying to build, like, something that you're going to be using quite a bit. But if it's something that's just quick use and throw, or um, or if you just don't have all that much time to spend, playing around with UI, because there's a lot of like state management that you have to do when you're building a complex UI, especially if the UI is going to have like multiple pages, or if one page is going to be divided into multiple, let's say virtual pages where you can select, or virtual tabs. Let's say if it's going to be divided into multiple tabs, and at a given time only one tab is visible, so when the user clicks on a button, it switches to a different tab, and then there's a different set of states and all of that stuff. There's a whole lot of state management. Dude, no, I'm not even gonna lie, there's a shitload of state management that you have to do if you're building a complex UI with Streamlit. And now that I'm saying this, I'm wondering if things would have been slightly easier with Gradio instead. I need to have a new conversation with Gemini. Give me a second. Do I have a thing open here? This time I'll use Flash because I don't want to run out of the thing. Is this my response? No, this is not the response. I don't think I need this anymore though. I think we are done with this, right? We read this yesterday. I think we are good. Oh, I can ask my question here. Okay, so once I have set up my project, I would like to use some of the libraries from HF Hub through HFT. Let's just, I don't want to type the whole thing. What are some of the smallest libraries that I can, not libraries, models that I can use that would be small to download, but more importantly, not super heavy to run on my mid-range system? Now, where I'm doing that clicking sound a whole lot without even like meaning to do that. I don't know why that's happening. Okay, anyways, hold on. I don't wanna forget this. What was? Oh yeah. Um, I'm trying to decide between Gradio and Streamlit. Okay, so we should get some info there. Here. Oh, we got an answer already. So we have for three different tasks. One is for general purpose text understanding, then for generative text, um, then, oh, four, then for vision tasks, and for audio tasks. Awesome. Awesome. Great. Are these small and like able to run locally? Oh, they have tiny versions of it. I didn't know that. Great. Awesome. Cool. Now, what's the answer here? Okay. Wait, no. Keep, yeah. Um, Try that response again, please. Um, there was some kind of loop detection error. In the meantime, there was another thing that we were doing here, right? Was it this? Yeah, we were talking about persistent storage. That's what it was called. Um, they actually call it persistent storage. Okay, of course, the workflow you've described is a very common and effective way to work with Hugging Face spaces. Let's break down how you do it and how to handle large file storage. The development to deployment workflow. The process is very similar to a standard uh, Git-based development workflow. Hugging Face spaces are essentially Git repos with built-in continuous deployment. I need to look into what continuous deployment means. Okay, create a new space on the web UI. Start by going to the, oh, I have to create a new space there. Okay, all right. Give it a name, a license. Oh, I'm going to be updating the space. So it's like creating a repo on GitHub. Okay, give it a name, a license, and choose the Streamlit SDK since you mentioned Streamlit. Mark it as private if you wish, then clone the space locally. Once the space is created, you'll get a Git URL. Oh, this is clever. Okay, I didn't think about it in this way. Yeah, so this way then I can run this thing locally, but also be able to run it on the space once I do push it to the space. Uh, okay, once the space is created, you'll get a Git URL. You can clone it to your local machine. Um, just like any other Git repo. All right, cool. Develop locally, cd into so and so. Now you can develop your application. you'll typically have app.py, requirements.txt, so and so, so and so. Test locally, okay, Streamlit run to run the entire application, that's fine. Then push to the space. Once you are happy with your local version, commit commit your changes and push them to the Hugging Face hub. Git add so and so. Okay, I can use Git UI for that. Great, awesome. Push. I think for the push, I might need to do that manually. I don't remember. But yeah, the add and commit and stuff that should be fine. Pushing to the main branch will automatically trigger your space to build and run your application. You can then visit so and so so and so to see and interact with your live app. Handling large files in storage. You are correct that you can't and shouldn't put a 1.5 GB file directly into a Git repo. For this, Hugging Face uses persistent storage. Think of persistent storage as a dedicated hard drive for your space that does not get erased when you push new code or restart the space. Give me a second. Where was I? Yeah, that does not get erased when you push new code or restart the space. Here's how you would use it. Enable persistent storage in your space, in your space's settings. You can request persistent storage. You can use, I have to request it. Okay. You can choose the size you need. Okay. Well, okay, here's the thing, right? I'm planning on making this available publicly. Oh, God. Let's hold on. I just loaded up Zentrea's stream and the volume is loud. Give me a second. Okay. All right. Where was I? Yeah. So since I plan on, oh, just a second. Okay. Since I plan on making this tool available to the public, um, I'm wondering if that's going to help my situation if I do requests for stories. This sounds super silly, right? But what if? Or I mean, okay, I can look into I it doesn't have to be free. I can pay for it. Upload your large file. Once enabled, a file tab. Wait, okay, this is important. Once enabled, a files tab will appear in your Spaces repo page. You can use this web interface to upload your large input file directly to the persistent storage. This is a one-time upload. Access the file. Your script can then access this file from a special storage directory. Okay, you mentioned this is a one-time um, upload. I'm gonna need some more info on that. Um, and also, what if I need to switch out files once in a while? Like, for example, if I'm building a tool that is supposed to process a 1.5 GB Twitch VOD file, and Yeah, a 1.5 GB Twitch VOD file, and then give timestamps for interesting sections in the VOD. Okay, there was another conversation that was going on, right? Here. Okay, both Gradio and Streamlit are excellent Python libraries for building web interfaces for machine learning and data science, but they have different strengths. Here's a comparison. Here's a comparison to help you decide. Gradio, strengths, simplicity and speed. Extremely easy and fast to create a user interface for your models. You can often get a basic demo up and running in just a few lines of code. Focuses on ML models designed specifically for wrapping machine learning models and creating interactive demos. It handles various types of data. It handles various data types like images, audio, and text seamlessly. Easy sharing includes a built in feature to generate a public shareable link to your app, which is great for showcasing your work. Hugging Face integration. It's deeply integrated with the Hugging Face ecosystem, making it easy to deploy and share models. I think I should take that into account. Weaknesses, limited customization, offers less control over the layout and appearance of your applications. You are somewhat constrained to the standard Gradio interface. In this case, and specifically when we are talking about creating a functional UI, I don't think that's a bad thing. Not ideal for complex dashboards. While you can create multi-component interfaces, it's not as well suited for building complex multi-page dashboards with intricate layouts. Then Streamlit. Strengths, flexibility and customization. It provides more control over the layout and appearance of your application, allowing for more complex and polished user interfaces. Data centric. Excellent for building interactive data dashboards, visualizations, and data exploration tools. Larger community and more components, has a larger and more mature community, um, which means more resources, tutorials, and pre built components are available. Good for prototyping and MVPs. While not as fast as Gradio for a simple demo, it's a great tool for building more feature-rich prototypes and minimum viable products. Okay, that's what MVPs means. Weakness, slightly steeper learning curve. While still easy to learn, it has a bit more to it than Gradio. Sharing is less integrated. While you can deploy Streamlit apps, it doesn't have the same out-of-the-box one-click sharing feature as Gradio. Okay, here's a quick guide to help you choose. Use Gradio if you want to quickly create a simple demo for your machine learning model. You need to share your work easily with others for feedback. You're a beginner and want the simplest possible way to build an interactive application. Use Streamlit if you need more control over the layout and appearance of your application. You're building a more complex data dashboard or application. You need to integrate with a wider range of data visualization libraries. I am tempted to go with Gradio for now. As much as I already have experience with Streamlit, I'm actually tempted to go with Gradio. Though I feel like whatever I'm going to be trying to design with Streamlit or with Gradio, that could be very easily designed with Streamlit, right? The quick and dirty stuff that I might design with Gradio. No, let's say I have some knowledge and experience with Streamlit already, which that's the case for me right now. The quick and dirty stuff that I might design with Gradio, I can easily do that with Streamlit as well, right? There was another question I was asking here, right? Yes, okay. That's a great clarifying question, and your Twitch VOD example is perfect for this. You're right to question the one-time upload. Let me be more precise. It's a one-time upload per file, not a permanent, unchangeable fixture. What? Hold on. Okay. Wait, let's just go with it. The key idea is that the file is managed independently of your code. You can definitely switch out the files whenever you need to. Here's how you would handle this for, oh, so the storage, the persistent storage is for one file. No, I think I'm getting that wrong. Yeah, no, I think I'm getting that wrong. Hold on. Let's continue reading. How to switch out. You have two main options to manage your persistent storage. The manual way, which is using the web UI, this is the most straightforward method for occasional changes. Go to your space on the Hugging Face website, click on the Files and Versions tab, navigate to your persistent storage directory. You can delete the old VOD file and then use the add file so and so to upload the new one. The next time you run your app, it will find the new VOD file in the storage directory. Okay, the programmatic way, which is so and so. For a more streamlined, terminal friendly workflow, you can use, okay, that's fine. Your Twitch VOD workflow in practice. So your complete workflow would look like this. Develop, build, and test your Streamlit app locally. Deploy with git push, process a Twitch VOD. Okay. I'm still a bit confused about persistent storage. Is it literally just one file that we can store on there? Where exactly does the one-time thing come in? Also, what am I paying for this storage? Okay, we are here. Yeah, okay. Yes, that's a fair assessment. If you're already comfortable with Streamlit, you can definitely use it for the same kinds of quick and dirty tasks you might use Gradio for. Here's a breakdown of why that's the case. Python based, okay, component based, both use component based approach. Rapid prototyping, both are designed for rapid prototyping and getting a functional interface up and running quickly. Why you can use Streamlit for quick and dirty tasks. Simplicity is still a core principle. While Streamlit offers more customization, its basic usage is very straightforward. You can create a simple interface with just a few lines of code. Great for data exploration. If your quick and dirty task involves visualizing data, or showing the results of a data-driven model, Streamlit is particularly well suited for this. Flexibility for growth. The advantage of using Streamlit is that if your quick and dirty prototype needs to evolve into a more complex and polished application, you're already on the right platform. You won't have to switch frameworks. Okay, all right, that's all. That's all the assurance that I needed. Okay, I guess we are just in time for this. You're hitting on some really important distinctions about persistent storage that can be confusing. Let's clear that up. It is literally just one file that we can store on there? No, absolutely not. Persistent storage on Hugging Face Spaces is essentially a mounted directory, often available at so-and-so, inside your space environment, or a path you specify. You can treat it just like any other directory on a Linux file system. This means you can do so and so, so and so, so and so. It's your own dedicated storage volume attached to your space. Where exactly does a one-time thing come in? My apologies for any confusion there. The one-time upload refers to a few key aspects contrasting with other storage methods. Persistence across code updates. When you modify your app and git push to your space, the files in persistent storage remain untouched. They don't get re-uploaded or overwritten. Okay, persistence across restarts and reboots. If your space restarts, anything in persistent storage will still be there when it comes back online. This is unlike the ephemeral temporary storage, which gets wiped. Okay, manual programmatic management, not Git. You upload a file to persistent storage once through the Hugging Face UI's file tab or via the CLI. This upload process is separate from your git push workflow. If you replace the file later, you perform another single. Oh, that's a one-time thing. Okay. Yeah, okay. So for your Twitch VOD example, you might upload so-and-so, your app processes it. When you get so-and-so, you use the UI or the CLI to upload that as well and override this, and that's your one-time upload. Okay, okay. What am I paying for this? Hugging Face spaces operate on a tiered system, free tier. Many spaces, especially those using CPU and standard resources, include a certain amount of persistent storage for free. Oh, that's interesting. This is often sufficient for initial development and smaller projects than the paid tier. If you need more persistent storage than what's included in the free tier, or if you're using more powerful hardware like GPUs, you will typically pay for it. That's fair. The pricing model for additional persistent storage is usually per GB per month. Yep, that's fair. That's fair. Now I just need to find out how much we are paying for storage. Is it mentioned somewhere here? This is endpoints. Give me a second. Um, let's go here and see. Oh, let's see under this. Oh, free mode is not mentioned here. Um, yeah, the storage is not mentioned here that I can see. Let me look this up on another machine. Hold on. Hugging Face spaces storage. Yeah, let's just look that up. Storage limit. Okay, storage limits. Let's take a look at that. Oh, that's interesting. So you have up to 100 GB of private storage, and public storage, it says best effort is usually up to 5 TB for impactful work. I'm gonna need to see because they have like asterisks and stuff mentioned here. I can open this up here. Hold on. It's it's wild that it's not mentioned under pricing. This comes under the hub documentation. Hugging Face Hub, um, spaces. Yeah, let me just look this up. Give me a second here. Um, okay, so they have two things here: persistent storage and just storage limits. Both are being mentioned here. Fortunately, it showed up in this, but it didn't show up in the other search results. Fortunately, it showed up here, so that's good. Okay, storage limits. At Hugging Face, we aim to provide the AI community with significant volumes of free storage space for public repositories. We bill for storage space for private repositories above a free tier. Storage limits and policies apply to both model and dataset repos on the hub. We optimize our infrastructure continuously to scale our storage for the coming years of growth in AI and machine learning. Um, okay, we do have mitigations in place to prevent abuse of free public storage. And in general, we ask users and organizations to make sure any uploaded large model or data set is as useful to the community as possible, as represented by numbers of likes and downloads, for instance. Finally, upgrade to a paid organization or user pro account to unlock higher limits. So here it says you have up to 100 GB, which is way more than what I need. So that's great. Beyond the first few, okay, hold up. The asterisk is for public storage. We aim to continue providing the AI community with generous free storage space for public repositories beyond the first few gigabytes. Please use this resource responsibly by uploading content that offers genuine value to other users. If you need substantial storage space, you will need to upgrade to Pro, Team, or Enterprise. That's fair. Yeah, that makes sense. Um, where's that arrow or a cross? I'm not sure. I'm not sure what that's supposed to be. Okay, we work with impact. Oh, that's I believe here. Oh, it was this thing. We work with impactful community members to ensure that it is as easy as possible for them to unlock large storage limits. If your models or datasets consistently get many likes and downloads, and you hit limits, get in touch. Okay, pay as you go price. Okay, all right, cool. Then we have the disk usage and spaces. Every space comes with a small amount of disk storage. This disk space is ephemeral, meaning its content is lost. Okay. If you need to persist, if you need to persist data with a longer lifetime than the space itself, then subscribe to a persistent storage upgrade or use a dataset as a data store. You know what? It's good to know that that is an option for me as well. Yeah, yeah. You can upgrade your space to have access to permanent disk space from the settings so and so. Okay. Um, though it cannot be downgraded to a smaller tier, if you wish to use a smaller persistent storage tier, you must delete your current larger storage first. Okay. All right. Oh, hold on. This kind of changes things a little bit because here it's showing something different. Does this, wait, what we saw over here, does this not apply to spaces? Yeah, I'm guessing this probably doesn't apply to spaces. This might not apply to spaces. Okay, you know what? That's okay. We'll find a different way to go about this. All right, that's fine. That's fine. Okay. Give me a second here. Just a second. Wait, what is this? Okay. Well, I can't type in there anyways, so just a second. I'm Okay, you know what? Yeah, I don't think actually. I don't- I'm not sure if I should raid someone or. Oh, you know what? No, yeah, we will raid someone. This is somebody that we have raided multiple times in the past, actually. They're a pretty chill person. They're a teacher. Um, Usually they're working on like syllabus or curriculum for their kids, their students. Um, like I said, they're a teacher, so they're usually working on that kind of stuff. Right now, let's go and see what they're doing. This person is Bayfinger and Baljeet, and yeah, yeah. So that's gonna be it for today's stream. I think I need to rename this stream to "Exploring Hugging Face" rather than anything about Transformers because it wasn't just Transformers. We were supposed to do Transformers stuff, but then uh, didn't really go in that direction. But yeah, anyways, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.